Hello, we're going to get started on 7.3 lesson, which is logarithmic functions as inverses. The first example is going to be exponential equations to logarithm form. So please write this equation off to the side. We have base b to the y power equals x. This would be exponential form. And then if they ask you to put it in logarithm form, you'd have log of base b of our x goes here equals our exponent y that goes here. So for this first problem, we have 100 equals 10 to the second power. So if we wanted it in logarithm form, we would put log a base, our base would be 10, of 100 equals then our exponent, which is 2. Now if we wanted to check our work to make sure that we have it correct, how we would type it into our calculator is log of 100 divided by the number that's lowered goes in the denominator, so log of 10. So our log button is right next to the 7 in this first column. So we have log of 100 parentheses divided by log of 10. We click enter and you'll notice we get 2, so we have the correct answer. This next one, we have 81 equals 3 to the fourth power. So if we want it in logarithm form, we would have log of base 3 of 81 equals our exponent, which is 4. The next example, we have 36 equals 6 to the second power. So the log of base, our base is 6, of 36 equals our exponent of 2. And again, if you wanted to check them, how you're going to type in, for example, this third one into the calculator, you'd click log of 36 divided by log of the number that's lowered goes in the denominator, so log of 6. Click enter, and we end up with 2. Now this next one, we are evaluating logarithms, so we have log of base 8 of 32 equals x. So we want to solve for our x. So we can do this two different ways. The first method is by hand, so we can switch it is in logarithm form, switch it to exponential form. So we would have this number that's lowered is our base. So our base is 8 to the x power equals then 32. So we're switching it the reversed order. It's in logarithm form, we're switching it to this exponential form. And then from here, we want the bases to be the same. So if we do our factor tree for 8, notice we get 2 and 4, 2 and 2. So it's 2 times 2 times 2, or we can rewrite that as 2 to the third power. And then 32, if we do our factor tree for that, we get 2 and 16, 4 and 4, 2 and 2. So we get 1, 2, 3, 4, 5 2s, or 2 to the fifth power. Notice at this point our bases are the same, which is what we want. And then right here we have power to a power, so we multiply those. And then if our bases are the same, both sides are equal, then our exponents also have to be set equal to one another. So we're just going to set our exponents equal. So 3 times x is 3x equals our 5. And then we're going to solve for our x. So divide both sides by 3. Our 3's will cancel out, and we get x equals 5/3. So that would be our final answer. By the calculator, if you want to put it into your calculator, you're going to put log of 32 divided by, and then the 8 is lowered, so we put that in the denominator, so log of 8. So if you're putting it into your calculator, you click your log button right next to the 7, log of 32 divided by log of our 8. We click enter. Notice it gives us a decimal. If you want it as a fraction to check your work by hand, just click on math. FRAC stands for fraction. Click enter, enter, and it'll give us 5/3, which is the exact same thing. So for this next one, we have log of base 5 of 125 equals our x. So we're going to do it by hand method first. We're going to switch it to our exponential form. So our base is 5, so we have 5 to the x power equals 125. And then 5, we can't do a factor tree for 5, so we just keep that side the same. But 125, if we go off to the side, make our factor tree, we have 5 and 25, 5 and 5. So our factor tree would be 5 times 5 times 5, or 5 to the third power. So we're just rewriting it, we're not changing the value of the problem. Notice our bases are the same. If both sides are equal, the bases are equal, then the exponents must be equal. So we just set our exponents equal to one another, so x equals 3. Then if we're going to do this on our calculator, we're going to type in log of 125 divided by log of 5. So let's check our work. Log of 125 divided by log of 5, and we get 3. And it doesn't matter to me which method you use to solve for it, whichever method works. This first method, be cautious though, it does not work if you cannot get your bases the same. Alrighty, these next ones we're going to take a look at just the graphs in terms of them. So for this first one, it's y equals log of base 3 of x. So to graph this, we're going to go to our graphing calculator. We're going to type y equals, and then how we're going to type this into our calculator is log of x divided by log of 3. It's our log button right next to our 7, log of x, parentheses divided by log of 3. We're going to click a graph. And I'm going to change my windows to zoom and then standard just so it's from -10 to 10 and -10 to 10 on the x and y axis. And notice this is the graph I get. So when it says graph it, we're just going to sketch that graph. Okay, so it looks like this. And then it's going to ask us some questions. So if it asks for the domain is the possible x values. So our possible x values, notice right here on our y-axis, it's everything greater than that. It doesn't go over here across that. So we're going to just say x is greater than or equal to 0. Our range is our possible y values. So our possible y values is all real numbers. Notice how the arrows keep going further and further to the right and higher, and then our arrow down here would keep going lower and lower. So every possible y value works. So it's just all reals. Our y-intercept, where it crosses the y-axis, notice it does not cross this y-axis. It approaches it, but it does not cross over it. So there is no y-intercept, so we just put none. And then our asymptotes is where can we make a vertical line that it approaches but does not cross. So notice right here at x equals 0, I can make a vertical line. It approaches it, but it does not cross that vertical line. So our vertical asymptote would be x equals 0. Alrighty, for this next one, we have y equals log of base 4 of x. So we're going to type that into our calculator. So we have log of x divided by log of 4. We're going to click graph. Notice it looks very similar. So we would sketch that graph. Our domain is going to be the same, that it is just x is greater than or equal to 0. Our domain is our possible x values that you're looking for. And so notice it never comes here to the left of 0, 0. It's just to the right of it. So x is greater than or equal to 0. Our range is our possible y values. Notice that this arrow keeps coming down. It keeps going higher and higher if we would expand out on our graph. So our range is all reals. Our y-intercept, it does not cross the y-axis. It approaches it but doesn't cross it, so there is no y-intercept. And then our asymptote, since it approaches the vertical line x equals 0 and it does not cross it, that would be our vertical asymptote, x equals 0. And lastly, we're going to take a look at some transformations. So we have this equation y equals log of base 4 of x minus 3 plus our 4. So inside of our parentheses is in charge of moving the graph left and right. On the outside is in charge of moving it up and down. So for this one, it's the opposite of what you would think, that it's going to the right 3 and then it's going up 4. And our parent function, if we're curious what our parent function would be, it's y equals log of base 4 of x. And again, our transformations, right 3 and up 4. This next one, we have y equals log of base 4 of x plus 5 minus our 3. So our parent function is the same. It would be log of base 4 of x. This one's moved to the left 5 and then down 3.